So in the last classes we saw about what the what does we saw about the disc domain model, and we saw about what is the how we have to identify the domain model, and what is the description class, and what are the association in it, and how we have to do the multiplicity. All these things we saw. The next topic as per your syllabus is we are going to look into the next topic what I am going to look into is the class diagram. So whatever we saw in the domain model, the main difference between the domain model as well as the class diagram is the domain diagram and the class diagram is that in the domain model we are not conceptual class, we are not concentrating of the methods, but in the class diagram you will be very you might have aware that the class has a method in it. Whatever you studied in the hoops, the same thing. How here we are going to look how we are going to frame for what purpose we need a class diagram, and how we are going to create a class diagram, and what are the association and what are the aggregations we have. All these things we will look here. Okay, so what is the class? What is the UML class diagram? And what kind of information does it have? Why we need this class diagram? All these things we'll see. So in the design phase, we are going to specify the structure of the software system, and we are going in this we are going to look then how what the system will do. Instead of thinking what the system will do, we are going to look into how we are going to do it. Okay, that is the main difference. A transition from what the system must do to how the system will do it. That is why we are going to concentrate. And what are the classes we need to implement the system? For example, we have a student. If I'm going to develop a software for examination monitoring system, then I have to decide what are the classes I should have. I should have a student class, I should have a faculty class, I should have a examination system, and I have a registration class. So do we have to identify what are the classes we need, and in each class what fields I should have, what attributes I should have, and then what are the methods in each class I should have. All these things we have to finalize. So that is what it is going to tell about, rather than what the system must do, and it is going to tell about how the system will do it. That is the main difference between uh, the domain model and this one. So here we are going to think about how the system is going to do, what are the classes we need, and what are the attributes we need, and how the what method should be involved in each and every class. All these
மேம்
things here we are going to tell me.
அட்மிட் பண்ண சொல்றேங்க மேம்.
Okay, okay. Slides now. So in this, how we are going to design the class. So we already I told you that mostly the noun phrases will represent the class names, and the verb phrases will represent the and action words will represent the association names. Okay, so the nouns are the potential. Here they have given that is the nouns are the potential classes, objects, and fields, and verbs will become the methods and responsibilities of the class. For example, a student registration system, for example, examination registration system. What is it? I told class student becomes a class name. But what is registration? It is an action word. So it becomes the method of the student. And similarly, I have faculty, a class name, and faculty registration, or they will act as a in the proctor examination. What we have, they are acting as a online proctor. So proctoring will become is an action word. So it becomes a method. So in this, all the nouns will become the class name, and your action words will become your methods or responsibilities. Both methods and responsibilities are same. Okay. So for example, here they have given a cyclic return system. Here they have given the what are the classes we have, that is place orders. they are giving the examples. They have given the customer, he places an order. You have to know the address, we have to know the number, we have to know the order history. So these are the attributes. And what is the action word we'll have? He is going to order the food, so we can have it as a method. So these are we are going to sort out for each and every class. We are going to identify what will be the class and what will be its attribute and what will be its methods or responsibilities. Okay, and next to this class diagram, we will have in the next chapters, we will see the sequence diagram. We will see gist of the sequence diagram in this unit, and then later we will see the entire sequence diagram in your next units. Okay. So, how will they have this NeoML? How they are giving the how they are giving importance to the class diagram. That is, what is an UML? I have already told it is an unified modeling language, and it is a common standard. Okay, after a number of people they research and they develop this standard. It is not any kind of language. A number of people do done research, and they have developed. If we follow this unified modeling language, it will be easy to develop the software without error, or we can develop the software within the specified time, or we can reduce the cost. Okay, for all these reasons, we are going for this UML. So they have given it as a lot of companies are using this UML. And UML, what does a UML will have? It has a formal syntax. Okay, it is a descriptive language. It has a formal syntax, and we are using the different diagrams and notations right from your use case till your deployment diagram. We are having the different notations to represent how each diagram should be, whether it depends on the flow of events, or whether it depends on the communication between the objects, or how it transits from one action to another action. Depending upon that, we have the use case diagram, class diagram, domain model, and we will have the sequence diagram, and next we will have the state chart diagram. All these things, depending upon the deployment diagram, component diagram, all these we are having in order to, it's just like a blueprint. If we're going to build a house, we'll have a blueprint. Based on the blueprint only, we're going to proceed with the construction. Similarly, here, all these diagrams will act as like a blueprint for your to develop a software in an effective way. Okay. So what are they have given the different, how the UML can be used. It is a repeater 2 mark question. How this UMLs, what are the three ways of specifying the UML? It can be used as a sketch, or it can be used as a blueprint, or it can be used as a programming language. So first one is how we are going to use it as a sketch. For forward, we are going to do the UML design before coding. And for a backward design, what you're doing the UML coding after the as a documentation. Okay, so that is one is it is used for forward design, or it can be used for the backward design. And next one is UML as a blueprint. Here we are going to use it as a complete design. That is, it is a computer aided software engineering tool. There are a number of tools available in your. Actually, what we are going to use, I'll show in the next class. That is, we are going to use the star UML, okay, or agro UML we can use, or we can use the rational rows. It is a, we are going to, all the components will be a built-in, and you are going to drag and drop, and you are going to draw the diagrams, okay. Whether you are going to give association or generalization or whatever things we need, whether I'm going to draw the use case, all the tools will be available, and we are going to drag and drop, and we can draw the diagram. So it is given, it is a, I can use it as a blueprint, or we can use it as a programming language. That is, when we completely draw the diagram, and based on that, we can auto generate the codes. Okay. In the rational rules, with the help of the class diagram, we can generate the codes also. Okay. So that is what they have given here. And what are the So what is the UML class diagram? So a picture of the classes in an OO system, their fields and methods, and the connection between the classes that interact or inherit from each other. All these put together, they form a class diagram. That is, what are the relationship between the different classes, methods, and their fields, and the connection between them. All these put together, they form the UML class diagram. Okay. So next one is what are um, something how what are the things that will not be represented in the class diagram is how the classes interact with each other. That we'll see in the next, that is sequence and interaction diagram. We will see that is interaction diagram, which is a combination of sequence and communication diagram. We will see in the iterants, that is, that will not be clearly identified here. That is how different classes interact with each other. That will not be mentioned here. Here they will mention, that is, what are the classes we have, what are their fields, and what are the methods. Methods is are their responsibilities, and how they are, how the different classes inherit or interact with each other. Okay, that is what a class diagram will do. So, what is the representation of a class diagram? Look into this here. So this is the rectangle. This shape is the representation of the class diagram. The first row we are having three division. First division represents the name of the class. Look into this. They have the name as a rectangle, and second division will have its attribute. That is, we have the attributes as width, height, and area. Width in integer, height in integer, and they have given the area in double. And next we have the methods. What are the methods we have? We are going to find the rectangle. So with integer and height integer, and we are going to find out the distance. So r of rectangle is equal to double. So these are the methods involved in it. Okay, so that is they have given the class name in the top of the box. Yeah, we can use it with this in this manner, within the double less than symbol, less than or greater than symbol. Within that we can write the which interface it is using, and we have to include all the attributes. So these are the attributes, and next one is we have the methods. Okay, so what are the methods? Similarly, they have given one more example, that is the class name is student. So the name will be given in the form of a string, and id will be given in the form of the integer, and we are going to find out what is the get id. That is, we are going to get the id, and we are going to get then these are the methods what we are using here. Okay, these are the methods we are using here. That is get id, get name, get email address, and get the total number of students. So these are the methods which are involved here. So this is an you are well aware what is a class. So a class which will have a class name. What is the need of for the attributes? They will describe the class. And what is the need for the methods? If we want to extract the data, we need to call the methods to extract the data. Okay. So for what purpose we are using all this thing? So if it is a car, name of the, if you have a attribute, or if you have a class name car, if I want to describe the car, then I have to include the number of attributes. Attributes are used to describe the uh, class. Okay. So next one is and we in that look into one more thing. We have given the visibility. So what does that visibility here represents? In the case of attributes, the attributes can be publicly available, or it can be a private, or it can be a derived attribute. Okay, if it is public, then we are using the notation it as plus. If it is protected, we are using it as hash. If it is private, hyphen. Or if it is a package, you are using the tilde symbol. And if it is a derived attribute, then you are using the slash. Okay, forward slash. And next one is and one more thing, if I have underline, then it represents that it is a static methods, and whether we are using a constructor, all they have given an example how to call the method. Okay. The next one is we can have some comments. What does a comment represent? It is used to describe what it is being done here. For example, here they have given a comment. Clonable is a tagging interface with no methods. The clone method is defined in the object class. Okay. So here this clonable is described using this comment. We know that we are using comments. Whenever a third person looks into your programming, he can understand by if you're using a number of commands, he or she can easily understand what you are going to described. Okay, so here the array list, that is we have an interface clonable. This clonable here giving it as a tagging interface with no methods. The clone method is defined in the object class. So this comment will clearly explain what this clonable is meant for. And next one is we are going to look into the different kinds of relationship between the classes. So we have already seen the same thing in your use case as well as in the domain model. Same thing. That is what is a generalization relationship and inheritance relationship. That is, if it acts like a parent-child relationship, then we call it as a generalization relationship. Okay, and next one is it is the inheritance between the classes, and if we are going to use the association. So what is the association? Association can be in the form of a dependency, or it can be an aggregation, or it can be a composition. Yeah, we will see this one by one in the next slides. So what is the generalization relationship? Look into this. We have the broad category as shape. What is the sub? The shapes can be we can have a different circle, rectangle, square. We can have flat shapes, or we can have a 2D shape, or we can have a 3D shape. But shape is becoming the broad class. Just a minute. So shape is the broad class, and in that I'm having a subclass as rectangular shape, and in that I'm again having it as an rectangle. So generalization, it is in hierarchy. That is, the broad category is shape. In that I'm having the rectangle shape. Okay, so this is what they have given. Generally, if I have the student and QG and PG, then it becomes the subclass. Similarly, broad category is shape, and in that I'm going to look into only one shape, that is the rectangular shape. Okay, so that is they have mentioned here. Next one is hierarchies are drawn top down with arrows pointing towards the parent. So look into this rectangle points towards the rectangle shape, and the rectangle shape point towards the shape. Okay, so this is what they have given, and the top down arrows, remember, top we have the parent and below that we have the child. Okay, so the classes will be represented in the solid line and black arrow. An abstract class will be have the solid line with white arrow, and interface, that is, will have the dash line with white arrow. So look into this. We first one is we have the class with the solid line, and above that we have a abstract class. What is it? Sorry, interface will have the dash line, and we have the, if we have the abstract class, we will have a solid line with the white arrow. White arrow means it is not filled. Okay, that they have mentioned it as white arrow. So this is a normal example to clearly explain what is the generalization. So keep in mind, generalization will always have the will have the property of inheritance. That is, inheritance the characteristics of the parent class. So here shape is a parent class. From that we have a rectangular shape, and from that we have the rectangle. And everyone all the things they have given the attributes, and they have given the what does the attribute is meant for. Okay, so next one is what we have. Next comes your association relationship. So association relationship will always depends on the how the two classes are related to each other. For example, I have a customer and or you have a ATM machine and a bank. So one class is ATM machine, another class is bank. Means how these two are related. Whenever I want to check the verify my PIN number, or if I want to verify my withdrawal or balance, I have to look into the I have to verify the details with my bank. So A and B are associated. Similarly, this is what they have given. And how they are associated. A particular bank can have a number of ATMs. So 1 to any. And similarly, Different banks can have different ATMs can have different set of banks. So it can be many to many also. So that is what they have given. Association relationship. We have multiplicity. Multiplicity means how they are connected, whether it is a one-to-one relationship or one-to-many or many-to-many or exactly one or exactly three, which you already seen in the last class also. That is, it is star means many, 0 to 1, 0 to many to 0, 1 or more, 1 to 1, or it is 2 to 4, or it is 3 or more. Okay. So what is the multiplicity of association? If it is one to one, for example, each student will have a ID card. So it is an one to one relationship. And the rectangle list will have the rectangle. Okay. So one to many. One rectangle list can contain many rectangles. List in our Gore list now, but it will contain a number of rectangles. For example, only I have a student list. I can have a number of students. Okay. So student list will have a number of students. So that is one to many. And next one is comes to the part of aggregation. So which we have seen earlier in the domain model, same thing. What is an aggregation? Aggregation is a part of relationship. So we are using the unfilled diamond symbol to represent the aggregation. So car and engine. So engine is a part of the car. Okay, so it is. And composition, because the car contains different parts, not only engine. A car contains engine, car contains the wheels, car contains the body of the car, and next it has a steering. All these things combinedly it makes a car. So we call it as a part of a relationship. Look into the second example, composition. Look into the symbol. What is the symbol for composition here? Here it is the unfilled diamond. Here we have a filled diamond. So what it is? It is a book is entirely made up of pages. So we call it as a stronger relationship. Okay. So without pages, the book is entirely made up of pages. Okay. So without pages, whether there can be any book without pages? No, it can't be there. So we call it as a stronger relationship. But without an engine, with a car cannot run. But we can call it as a car only, because even if it without if it is having a audio system, with an audio system, the car is working. So we call it as a car only. But without a book, without in a book without a page, a book is not. I can't call it as a book. Okay, so it is entirely made up of pages. So it is a stronger relationship, or it is an entire we what composition we call it as an, it is entirely made up of pages. So it is an composition relationship. Here it is an aggregation relationship. And next one is dependency. What is dependency? We are using it as temporarily. If it is for a particular span of time, then we call it as a dependency. For example, here they have used as a use the symbol lottery ticket depends on the random number. Okay, that is a lottery ticket dependency, it is random. We were using going to use it as temporarily, then we call it as a dependency. For a particular span of time, I'm going to use this and I'm going to switch over to the next thing. In that case, we are going to use the dependency relationship. So when we need entirely for every, it is going to depend on the of this particular part, then we are going to use the relationship as composition. For example, car and steering, if um, it is not an automatic car, then we need a steering to drive the car. So it is mainly dependent on the steering. To drive the car, I need a steering. And if it is an aggregation, without car and audio system, even without audio system, I can drive the car. So it is an aggregation. It is a part of relationship. Composition, it is entirely made up, or it is entirely needed for the task to be completed. Then I call it as a composition. It may be needed, or I can do without this, then we are calling it as an aggregation. Okay, so it is part of relationship. Composition, it is a stronger version of aggregation where I need it completely for fulfilling my task. Dependency means I'm going to use it for a particular span of time, then I use the relationship dependency. So this is an example for a class diagram for the voting system. So look into this. What are they doing? We have a what are the classes we have? We have a voter authentication. We have a ballot creation. We have a secure PW, that is how we are going to give the thing, and next we have the voter personal identification. So these are the different classes involved. We can have some more classes also. This is a sample representation. Look into this. In the case of voter personal identification, what does we have? We have the last name, first name, middle name. Next one is voter or SSN number. Next one is address one, which city he belong, which state he belongs, and we are going to validate the zip code, and we are going to validate the state. These are the methods involved. And similarly, for ballot creation, we have the ballot name, that is voting paper, that we call it a ballot paper, and what are the candidates involved in that particular election. How many candidates are contesting in this election? That is the candidates. And we are going to display the ballot, and we are going to create the ballot. And similarly, voter authentication. So, based on the personal information, we are going to authenticate the voter. So, voter ID and voter password, and they are going to give the secured how we are going to generate the secure password. So when once the password is entered, we are going to, how we are going to create the secured password, that is they have given. Okay. And similarly, uh, this is one more example of class diagram. What we have here, it is an just a minute. It is not clear. I'll go to this. This is the next one. We have the student address. So student, which how many student body we can have a number of students associated. So it is given as 1 to 10. Here in this example, this student body contains 10 students. So what are the attributes of the students? We have the first name, last name, home address, and school address. And I have one more thing, address as a separate class, and what does it contain? Here the address, it has given as a separate class. What does it contain? Street address, city, state, and zip code. So the address will contain the following attributes. Okay, what does this symbol it represents? It is a part of a relationship. That is, student is aggregated to the address, and student body and student are associated with the multiplicity 1 to 10. Okay, by looking into the diagram, we should be able to explain what does it depicts. Okay. So here how we can analyze the use cases, that is they have given usually nouns form the classes, and a proper noun implies the instant of a class, that is proper noun will give the object. For example, student, I'm having it as a class. Student 1, if I give it as a proper noun, student or a name which in a student, if I call it as a Ravi or Prakash, whatever it is, then it becomes a proper noun. So the proper noun will act as an instant of a class. What we call it as instant, it is an object. Okay, that is student. If I give it a student 1, then it becomes, what is it? It is an object. And a collective noun implies a class of objects made up of group of instance of another class. Okay, if I am going to make a collective nouns, if I am going to make a set of classes based on another class, then I call it as a collective nouns. Implies a class of objects made up of group of instances of another class. Okay, if we're going to create objects based on the instances of another class, then we call it as, then it is a collective noun format. And next one is already told, adjective. Adjective are the describing. What is an adjective? It is a describing word. If you want to describe a flower, it as a, uh, if you want, it is soft texture, vibrant colors. If I am giving to describe a flower with the, or if I am going to describe a dog, it is furry hair, snow like white in color. Or if I am going to describe a dog, then these words we call it as an adjective. Adjective is a describing word. Similarly, an adjective, all these will become the attribute of an object. Okay, whenever I use an adjective, because why I'm telling all these things, they will give only the customer or the they are going to give only the uh, summary of what they need. Based on this, we are going to derive what can be the class, what can be the object, what can be the method. So if you are clear, whenever we come across the nouns, we are going to form it as a class. And if it is an describing word of a particular, if it is a describing word, then we can convert into an attribute. Okay. and a doing verb implies an operation. And what we are going to do, doing verb means, then we call it as a method. Okay, so being a verb implies a relationship between the object and its class. So it going to helps whether it is an association or it is an aggregation. Okay, and a transitive verb will implies an operation. So this is what all these things they have given here to when I give the summary or they give going to give a task to you. It is an write up or a case study if I given to you. We from the case study we have to identify what will be the class name, what will be the method, what will be the association, where I have to use association, where I have to give aggregation. All these things we should be clear. For that only they have we are going to outline all these things. Okay. So when we design a class diagram, we should ensure that we should not miss any attributes or we should not miss any methods in the class, and we should not use any extra class or unused attributes should not be included to form a class. We should be very clear that what are the attributes needed and what are the methods needed, and whether this attribute and this method will be involved in my task. Okay, that's what they have given. We should not miss any attributes and we should not miss any methods, and at the same time, no extra or unused attributes or methods should not be included in the class diagram. Okay. So what are the things we should avoid the redundant classes, we should avoid the irrelevant classes, vague classes. So what do you mean by redundant? Repeated classes. Okay. If we have if we have a roll number, register number, if I have a class name like that, roll number, register number, R number, all are going to represent the same thing only. Then that is a redundant class. Or if I'm going to give student name, name of the student, all both are same redundancy. So we should avoid the redundant class. And similarly, we should avoid the irrelevant class. For a particular task, this class is not needed or it is irrelevant for a particular task. Then I should avoid that, and I should avoid the vague classes, that is which is will not be included. And similarly, I have to look into which attributes are needed, which operations are needed, and what other roles are needed or not. Okay. So look into this. This is an example for a sample diagram. Here we have a class called customer, and what are the attributes we have? We have the attributes as name and location. So what is the data type I'm using? String and string. And what are the methods we are using? Send order and receive order. And similarly, on the customer, one customer can make a number of orders. So what are the orders? If it is a food delivery system, imagine it is a food delivery system. We have the date and number. Okay, which order it is, and whether it is whether we have to think whether the order is confirmed or the order is closed. And in that we have to think, if it is confirmed, then we are going to proceed. If it is closed, we are cancel, or you can have it as cancel. And next we have the order can be categorized as two things: special order and normal order. So that is they have used the what is this triangle represents? It is a symbol for the generalization. So special order, we have the date, the attributes as date and number of the order, and similarly apart from that we have confirm, close and dispatch. Okay, in the case of normal order, what does it we have? We have confirm, close, dispatch and receive. Apart from the special order, that is no receive methodology. Here we have the receive method is included. So this is an example of the class diagram. Here we are using this is super class and it has the subclasses. So order is a super class, special order and normal order are the subclasses of the order. Okay, and there we are using the generalization symbol. Why are you using generalization symbol? Whenever I inherit a relationship or whenever I inherit a property, that is order is a common property in the case of special order as well as the normal order. Here we are inheriting the property. Then we have to use the generalization. Okay, and look into this. This is one more example. I'm going to try to look into a number of examples so that we can easily understand. So here it is for a seminar enrollment system. So we have a student as one class, and the attributes of students are name, phone number, email address, student, and average mark. And we are giving a condition is eligible. Then name and student number. Get the number of seminars taken. Purchase the parking pass. These are the methods. That is number of how many seminars a particular student has attended, and whether how to purchase the parking pass. And we have to next we have the attribute address. Look at this, and one student can enroll in any number of seminars. So that is seminar enrollment, and what is the mark he received. And we are going to have the attribute as get the average to date and get the final mark. And similarly, the seminar enrollment is associated with the seminar. So, how many seminars are there? And how many students are eligible to join in the particular seminar? So, we can add the student or we can drop the student. Okay, and after that, this will be done by the professor. Okay, so what are the details of the professor? We need a name, phone number, email ID, salary, and he or he should also purchase the parking pass. And next one is the address. So both student and the some professor, we need the address. So what is city, name, postal code, country. So these are the attributes of the address. And what course they are offering in the seminar. So that is they have given the name of the course, or what is the fees of the particular course. Okay. So this is an example for a seminar registration system of a student. So we have the attributes as to, sorry, we have class name as student, professor, address, seminar enrollment, seminar and course, and we have some criteria that is based on what basis we should enroll the student or we should drop the all these things you have to look into. Okay. So this is an another one example. Look into this. We have the customer and the order. The previous what I have in the previous same thing. We have a customer and order, and in this they have given the payment as a generalization model. For example, we have the payment. The payment can be done via three things. Whether it can be credit payment, or it can be a cash, or it can be a check payment. So if it is a credit card, then I have to enter the credit card details, and I have to check that I have to authorize the credit card details. If it is a cash, then you are going to do the cash payment. If it is a check payment, check spelling is CHEQUE, just verify it as. Then we have to authorize the check details. Okay, and similarly, we have one order. The order we can have the one. We can have a number of order details. Okay, so what is the quantity and what is subtotal and what is the weight? All these things we have, and each order will have the item. Okay, so what are the items involved in that, and we have to get the what is the shipping weight and what is the description of each item. So look into this. They have this is a generalization relationship and this is an aggregation relationship. Order will have the order detail, and the order detail and the item, it is a multiplicity. That is, one item will be involved in different orders, and similarly one order can have a number of order details, and one order we can have a number of payment method. Order can have a number of payment methodology. We can choose any kind of payment methodology. So this is what the relationship, that is what are the attributes, and how the blue color represents the association, and this 102 many represents the multiplicity, and this arrows represents whether it is a generalization or it is an aggregation, all, and what kind of multiplicity uses. All these things is depicted in this diagram. Okay, and they have given an example for a. These are some of the examples of vending machine. So vending machine and that is money dispense பண்ணுவீங்கல்ல. If I enter the amount, if it has a different products available, when I enter the amount, based on the amount I have to select the product will be automatically released to us. So that is what they have given. Look into this. We have a numeric keypad, we have a wireless keyboard, we have a CRT display. So we are going to type the details what we need, and it will be displayed, and we have a product database. Based on the product database only, the vending machine will control the end user. Okay, which product we are going to select, and it will detect the and we are going to enter, drop the money, and we are going to get the money back, and we are going to get the product back. Okay, this is an automatic vending machine. Uh, in some shopping malls and all they have, when we can automatically, for example, we have a automatic coffee vending machine. We'll have to insert the coin, we have to select whether we need a coffee or a tea and what kind of coffee we have to give, and based on that we have to insert the money and we'll get the coffee readily prepared. Similarly, it is a vending machine. They have not mentioned what product is that. General vending machine. And in railway station example, we have a automatic platform ticket. We can directly go and select the details which how many tickets we need, and we can enter the cash and we can get the tickets automatically. So this is a vending machine, and direct that we call it as a vending machine. So how it is connected? So we have a VM controller. The VM controller is connected to the CRT display, numeric keyboard as well as the wireless keyboard. And we have a money dispenser and we have a product dispenser. And apart from that, we have a database controller. Database controller will detect what product we are giving. So depending upon the task given to us, we have to sort out what are the attributes we need and what are the classes we need. Okay, and we are going to draw the diagram before we are going to actually code it. So go through the some more examples here. Satellite control system. Okay, so that is the tools I already told you. We can use rational rules or we can use a number of commercial available open source tools are available. We will see one of the tools by tomorrow's class. Okay, ma. Thank you for your patient listening. We have one more topic left. Tomorrow I'll complete this. One or two more topics. We'll complete this. In the next two classes, we'll complete this. Okay. Thank you for your patient listening. Now we can leave the class. Thank you, students.